Hello and welcome to the solving equations video. Hopefully that makes you happy. Happy as the monkey that you see on your screen now. So we're going to open up here with another monkey problem. So a monkey is chasing you. You run 5 feet per second and have a 12-foot head start. The monkey runs 7 feet per second. In how many seconds will the monkey catch you? A lot of ways we can answer this. We could act it out if you have a monkey that's trained to chase you, or we could do a chart. That's possible. But we're going to show you how to solve this using an equation. But first, let's talk a few vocabulary words. In case you forgot, a variable is we'll use that throughout the video. A variable is a symbol or letter that stands for an unknown quantity. And what we're going to be doing in equations is trying to solve for a specific variable. And since we're talking about equations, think about an expression. So say we have an expression like 1 plus 1. Well, an equation is just an example of two balanced expressions. So 1 plus 1 and 2, we know they're the same because they are marked by this equal to sign. So we have an expression here, an expression here, balanced by an equal to sign. That's what an equation is. So equations have to have equal signs. Inverse operations we will be using to solve these equations. What do I mean by inverse? We're talking about the opposite. So if we're adding in an equation, we can do the opposite by subtracting. If we're multiplying, we can do the opposite by dividing, and vice versa. So let's still get our first kind of simple example. We have 15 is equal to 5 minus 2x. And again, remember what I told you, we're trying to solve for this variable here, trying to figure out what that could stand for. Alright, so first of all, what I like to do is draw lines around my equal to sign, because what I'm doing is clearly establishing a left and a right side. And once I have a clear established left and right side, I look for my variable. And there it is, x. So I'm going to use inverse operations and do the opposite of everything that I'm doing to the variable to get it isolated. Because these variables and these numbers, they don't like each other. They want to be away. Imagine they're at a party and variables don't like to be in the same room as the numbers. So I see this 5 right here is positive. So the opposite or the inverse of that is going to be a negative 5. And then I see a negative 2x, meaning negative 2 times x. So we're going to undo both of those steps. So the opposite of a positive 5 is a negative 5. Now, but the thing with an equation is they have to be true on both sides, or they have to be balanced. So if we have minus 5 on this side, we have to have minus 5 on that side. Okay? When that's all done with, we have 5 minus 5 is 0. It's gone. That's what we wanted. I'm going to bring down this minus 2x. And then over on the left side, it's 15 minus 5 is 10. And I'll bring down my equal to sign. So we don't really need to write that, the 0. But just know that that's what's going on, is that we subtracted it to get rid of it so that it's got away. It moved to the opposite side of the equation. Got away from that 2x because it hates the variables. Okay, so we have negative 2x. Remember, that means negative 2 times x. So the opposite or inverse operation that we're going to do is we're going to divide by negative 2. Remember, it's got to stay balanced. So if we divide by negative 2 on one side of the equation, we have to divide by negative 2 on the other side of the equation. And what we're left with over here, these will simplify to 1. Negative 2 divided by negative 2 is 1, or 1x. And 10 divided by negative 2 would give us negative 5. So, final answer in this case, x is equal to negative 5. If you weren't sure if you were correct, go back and plug this in to our equation. So we'd have negative 5 times negative 2. Well, negative 5 times negative 2 is 10. And then 5 is positive, so we're going to add 10 and 5, and we get 15. And look at that, both sides equal 15. That's how we know we're correct. So let's come back to our monkey problem. We can help solve this by using an equation. The reason we can use an equation is because we're really looking at two things. We're looking at u and we're looking at the monkey, and we want to know when they're the same. Okay, so we can make things the same by using an equation because we know that they're going to be balanced. So let's look at what you have. You run 5 feet per second and have 12-foot head start. The monkey runs 7 feet per second. So in how many seconds will the monkey catch you? Think about the problem. What are we trying to solve for? What are we trying to solve for? What are we going to try to solve for? We'll call it X. Yes, we're trying to solve for seconds. Yes, you are correct. If you said seconds, congratulations. You're brilliant. So, let's look at how fast we run. You run 5 feet per second. So when we say per second, it's times the number of seconds, which of course we don't know. So we'll call that X. 5 feet per second. And you have a 12-foot head start. So that 12 foot gets added to you. Versus the monkey over here runs 7 feet per second. So that's represented by 7x. Now, one thing that we haven't done yet is how to solve an equation when you have variables on both sides. Well, guess what? We have our variable party here. So here it is. On this side, whoa, that wasn't supposed to happen. On this side, we have variables, we have numbers, and we have variables. So let's think about this. Pretend the variables are you, teenagers, and you're at a party where there are adults, so the numbers are adults. Do you want to be in a room full of adults that like to bother you and make fun of you and show you pictures of and videos of monkeys? Or would you rather be in a room separated away from them next to the other teenagers? Well, I would be willing to bet you want to be in the other room. So let's move this 5x to the other room. And the way we move things is by doing the opposite operation. And I know this says 5x, but we're not going to get rid of the 5 just yet. What we're going to do is move the entire thing over by doing whatever it is in the opposite or inverse sign. So I'm going to subtract 5x from this side and this side to make it balanced. And we're just going to add down here. Again, remember that 5x minus 5x, that cancels out to give us just 0. So we have 12 on this side. And then 7x minus 5x is 2x. Well, now all we have to do is to get rid of, separate this variable from the numbers. Remember, teenagers don't want to be around the other numbers. So we divide by 2, because this is 2x, 2 times x, so we're divide by 2, which leaves us with x is equal to 6. So it takes 6 seconds for the monkey to catch you. Now for this next part, what I'm going to do is I would like you to try each problem. But after each problem, I will explain it, but I'm going to go kind of fast because this is a video, so all you have to do is pause. Okay? So why don't you try this first problem, starting with 12, and try to solve for x. Okay? Now, hit pause. Try it. Do you think you got it? This is how I would do it. I would subtract 12 from this side and from this side to keep it balanced, which of course would give me negative 36 on this side, and the opposite of the quantity of x plus 2. Now, if you didn't know what to do with this, you can treat that like it's a negative 1 times all of that, which means we can just divide both sides by negative 1. And that will get rid of that. And we have x plus 2 is equal to negative 36 divided by negative 1 is positive 36. So then we just subtract 2 from both sides and we get x is 34. Did you get it right? Hooray! Alright, now try the next one. I know, fraction. Scary. Okay, hit pause, give it a try. Now. Think you got it? Well, here's how I would do it. First step, we're going to add 5 to both sides, inverse operations, to give us 15 is equal to 3/4 x. Now, a lot of ways you can go from here. What I think is the easiest way is kind of treat this like it's a fraction or a proportion, and the x is in your numerator, so you end up doing a cross multiplying kind of way to solve this, and we have 4 times 15 is 60. 4 times 15, and then 1 times 3x is just 3x. and divide by 3 on both sides, we get x is equal to 20. Now if you did it a different way and still got x equals 20, that's fine. Good for you. But that's how I would do it. So now try this next one. 4x minus 9 equals 15x plus 90. Okay, I'm not even going to walk you through that. I'm just going to give you the answer. If you just pause, try it, just like what we did with the monkey problem. Pause. Alright, did you get x is equal to negative 9? That's the correct answer. If not, go back, try it again. Ask me questions tomorrow. We can go over that one. Next, we have this big problem. Oh my gosh, it looks so complicated. This is why we no longer try to do these problems in our head. I'll walk you through this one because it does look kind of intimidating. But if we just break it down into small parts, I see distributed property that we can do there. I see like terms we can combine there. We've done all that before, so let's keep going. Distribute with a little hua. Negative 3 times negative 2x is negative 6x. Negative 3 times negative 5 makes that positive 15. And I'm going to bring down the plus 9. Then on this side I'm going to combine a little bit of like terms because I can. And you can combine like terms if they're on the same side of the equation or the same kind of same side over here versus here. This we can combine like terms on the same side of the equation just by adding them up. We don't do the opposite unless we want to try to send it to the other side. So be aware of that. Students make that mistake all the time. Negative 2x and negative 2x, if we combine that, we're going to get negative 4x. Okay, and on this side of the equation, these two are like terms, so let's just combine those. We have negative 6x, 15 plus 9 gives us 24. Alright, now, in case you're wondering which variable you want to get to the other side, I would say we have a negative 6 here, negative 4x. If you want to avoid negatives, it might be easier to move this smaller number to the bigger side. It doesn't matter which side they go on. Just watch what happens. Negative 4x plus 6x gives you 2x. We still have 10 here. 2x is positive, so I'm going to put a plus there. These will add up to 0, equals 24. So it's okay that now the x is on the right side. That's fine. I'm just going to do the opposite. Subtract 10, and get 2x equals 14. And of course, last step, divide by 2, we get x equals 7. Not so bad. Again, if you want to check it, plug x into each of those as 7 and see if it balances out. I bet it does. Now, there's something weird about this last problem. You give it a try, see what you find. Hit pause. Did you at least get to this line in the problem where you have 3x minus 2 is equal to 3x minus 2? If so, did you notice that those are mirror images of each other? If you keep solving, eventually you're going to get x equals x. And duh, we knew x equals x, right? So, in essence, what this means is there are an infinite number of solutions. Infinite, it's beautiful handwriting, solutions, S-O-L-N, that's an abbreviation for solution. Or you can say it is an identity because it shows that both sides are equal. Okay, so if you solve your problem and then you get x equals x, you get identity. By the way, if you get a final answer where you get something like, and I'm going to write this in red over here, say you get 5 is equal to 7. That's not an identity because does 5 equal 7? Nope. That's an example where we have no solution. So if you get all the way down, simplifying everything, and you get two things that really don't equal, you would say no solution. If they equal exactly, that's called an identity. Alright, now it's your turn. I would like you to try these 4 problems, see what you find, hit pause, and do all 4, then unpause and come back to the next problems. Okay, answers are given. Questions? Alright, here are your answers. Did you get all these? No? That's okay. Ask questions tomorrow and we can discuss. Thanks guys. You've been great. I will see you tomorrow in class. Bye-bye.